So maybe we should try to start so that we don't lose too much time, because at this presentation here will be two parts. First, a general VISS update by myself and Ted Gild from Geotab. And then we will hand over to BMW, who will show a very interesting demo where they have implemented VISS. So we must find time for both of these. So therefore, I think we should start here. And therefore, in our presentation, Ted Gild, who is remotely connected to us here, will start. So I leave the stage to you, Ted.
Thank you. I can't see if the slides are up.
They are. We are on the very first one, VSS update. Maybe I should advance to next one.
Yes. Thank you.
What is VISS?
Yes. So VISS stands for Vehicle Information Service Specification. It's a complement to VSS, which I hope this group has learned a fair amount by now through other presentations. VSS is Vehicle Signal Specification, created at Covisa, formerly Genevi, and it's a common data model for vehicle signals. As people here are probably well aware, OEMs all do data differently. So there's a need for a common data model in order to be able to write code and create services that are more broadly used across the industry, as well as have a common way to interact and interface with those data points. So it's a common API for VSS. It leverages web technologies. VSS is done at W3C, the World Wide Web Consortium, so it makes sense that web technologies are used. It's also done deliberately, since most developers on the planet are not embedded automotive engineers. There's a lot more web developers, and they tend to be at the companies that you want to partner with and create solutions with. Its main use cases are VSS as a service can reside in the vehicle for applications, to be able to interact with the vehicle and collect information. It can be used for vehicle to cloud to have the same interactions, but from the cloud, and be able to bring data up to it. And also to run against data that's already been offboarded from the vehicle and reside in the cloud, so indirectly. So you can have an application over the internet that interacts with a digital twin of the vehicle. There's obvious safety and security reasons for doing so. VSS is mostly meant to interact with a single vehicle at a time, but of course you could have services that can use VSS to talk to them individually, sort of in bulk as well. Next slide, please.
Yep. Please.
So history of VSS. So the W3C working group started with a let's call it sort of a FAT API. A FAT API has a different method for every get or set of a data point. So get vehicle speed, get front left tire pressure, these sorts of things. That's rather onerous. It's how it actually started, or had got started by the time I got involved, which was about 8 years ago while I was at W3C. And the intent was to, not necessarily exclusively, but to be used in a browser runtime, to be used in a browser in the head unit in the vehicle. It was less focused on telematics, it's more focused on user interface, user interactions. There's intent on doing other APIs around audio and navigation and so forth. Meanwhile, we've seen how the industry has changed, and as has Genevi. Genevi rebranded and switched from an IVI focus to connected vehicle services. And so the group had done this quite a while ago. VSS, the data model itself that I mentioned that it relies on, that it uses to expose, was started by, I believe the original proposal was from Magnus Fuhrer. At the time, he was with Jaguar Land Rover. He's with Ambition now. And it was a common data model. And he presented that at a Geneva all-member meeting, and I saw the power and usefulness of it, and asked him, why are we doing something different as a different activity inside of, at the time, Geneva. And there's agreement and alignment, and we coalesced on it. RVI, Remote Vehicle Interface, did not continue within Geneva, but we're almost seeing it sort of revived as a vehicle service catalog, RPCs to remote procedure calls to vehicles. It's still a possibility. Anyway, VSS itself evolved into a very light API. The first version of it is very simple. VSS is exposed as JSON, and the only protocol the first version supported is Websockets. We know is in production Volvos, Polestars, and Jaguar Land Rovers. The industry is rather secretive, so there may be others. We also are well aware of a large number of proof of concepts. Volkswagen Group became interested because their VISS platform was somewhat similar, and for quite a while we tried to align with them, to no avail, unfortunately. VSS version 2 has some initial influences from Volkswagen. Ulf is going to go into the additional main features in far more detail, but it's primarily focused around more advanced filtering capabilities and access control, which was missing in VSS version 1. Next slide, please.
One question.
So at this point, VSS version 2 is, we consider it feature complete. We have essentially no outstanding issues. It is has a reference implementation that Ulf has created, and he's also the main editor, and will, as I mentioned, provide more details on the additional capabilities of VSS. But at this point, it's feature complete. What we need to advance in the W3C process is additional implementations. We have to prove interoperability. We have to prove industry uptake in order to advance it to the next and final stage. It's also very important for us to get feedback from people. What works, what doesn't, what can be improved upon, what additional features people want from VSS. It's sort of very important that we get that. The other point I want to make is, as a part of that, Ulf and I actually are involved in experimentation with VSS with an undisclosed OEM that's currently under NDA, but we are very interested and willing as a group to help other people evaluate and consider how they're choosing to use VSS, and see if we can help them and learn ourselves in the process. Next slide, please.
Yes.
As I sort of alluded to, standards don't sort of aren't created in a bubble. They aren't created in isolation. We need input. We need feedback. We need people to tell us what they like, what they don't like, what works. Share your ideas. You know, bring forward thoughts and additional features that we can bring forward. If you are adopting these various VISS standards, it's imperative that you stay involved. If you're not leading and providing direction, at least you want to be aware of the changes and be able to contribute in other ways, as far as knowing where the standard is going and how it's evolving, and sort of what next. So please do reach out to us. I think there's probably contact information available as far as the CVISS materials. Public-automotive at W3.org is the group mailing list. You can subscribe to that. Anyone can. You can reach me at tedguild@geotab.com, and we'll also provide his email address. And please, as I said, reach out to us. And with that, I'm going to hand over to Ulf, who will tell us more about VSS itself.
Oh, thank you, Ted. Right. So I will mention a little bit more about initially here about what's added compared to version 1, which was will not become a full standard, but it's a recommended proposal in W3C. So it's still usable and it's steady. But what we added was that, as Ted said, WebSockets was supported in version 1. Now we've added HTTP and MQTT. MQTT actually requires a little thin application level protocol on top of it, so to say, because we wanted the client to be payload compatible between WebSocket, HTTP, and MQTT. HTTP obviously cannot run the subscription requests because you don't have a session concept there easily, at least. The thing about this extra application level protocol, I will not go into detail, and it's very thin, so it's simple. You can read about it on GitHub. The client actually sends in the payload. MQTT has a topic and a payload that is sent. And the payload from the client actually contains the topic that the client will subscribe to. So then the server on the other side knows that this request, I should respond on this topic, and then it goes back to this client. So in that way, you can run every request that is supported in VISS version 2 is also possible to run over this MQTT plus application protocol. It all has to run over TLS to be secure. That's mandatory in the specification. I've missed to mention that here. But another addition that we have done is what we call a filtering mechanism. That is that the most basic request model is very simple. You can ask for to get or to subscribe to a single value. But you most likely as a client want to be able to have a slightly more nuanced or flexible way of describing what you want to have back. Maybe you want to have several signals back in one request, and then you use the paths filtering mechanism where you can actually add multiple signals and they don't have to be on the same branch. You can point out signals wherever in the tree and you will get it all back in one. Yes?
You're talking about the protocol here, aren't you? Not the reference implementation.
Now I'm talking about, I will come to reference implementation later. This is purely about the other protocol or the standard, what it supports and the additions in that, yes. So that's the path. You can have multiple signals in one request. You can, for subscriptions, have a time base. That is actually not addition. That was supported also in version 1. So you can say that I want every 3 seconds, every 5 seconds, or whatever. In milliseconds, actually, you express it. And then you will get callbacks, so we call it notifications in the terminology here, back. You can instead want to have it as a change when there is a difference between one value and the subsequent value. You cannot say 10 values later. You can only say the next value. But when you change between 2 subsequent values more than X, then you are interested to get the result. Otherwise not. And so you can express that. Range, you can say I want the signals when they are larger than 5 and upwards, unlimited, or you can say between 5 and 10, a bounded range. This is all supported. And very lately we also added the inverse of a bounded range. You can say I want every signal that is outside of this range also. We have added at the very end of the development here. We have something called history, which I think was partly or implicitly mentioned here before. That's a way of, or maybe in the earlier meeting that I attended. So you can actually, as a client, ask to get signals for a time period, which is of course dependent upon that the server supports that. If the server doesn't support it, just responds with an error message. But it could, and one use case for that is, for example, when a vehicle gets out of coverage. If the vehicle is intelligent enough to detect that and tell the server, which in an implementation and the reference implementation that we come to supports that. If some intelligence in the vehicle detects no coverage, no connection to cloud, it can tell then the server to record. And if that is implemented and it records, then afterwards, when the client reconnects, it could, for example, then do a history request for a time period, and given then that it was recorded by the vehicle, it will the protocol supports sending it all back, all the values. We call a value a data point. So data point is a value and a timestamp. So then you will have several data points sent back. Curve logging is a data compression method that is invented by Geotab, but Geotab has made it the license open for anyone to use, and hence it has been possible to include into W3C and Covesa since it's a license that anyone is allowed to use, and it can compress in, we think, a very fitting way. You can say that I only want values. I try to have a straight line between first and last value, and if that difference at any of the real samples is too large, I change the curve and point to that, and then I can get as few data points as possible that has together a smaller error than something that you have defined. So you can compress and say that I will compress and have as few values back as possible, but the error at any of the samples must not be larger than X. So that it works very well. We use it extensively at Geotab, and we think we wanted to make it open for anyone to use, which is then now supported here in this standard. We can also, a client can also ask for what we call static metadata, which is the actual VSS metadata. A server should have, and typically have, and the reference implementation have an instance of the tree with all metadata. And the client could then ask for it directly from the server. And it could ask for just parts of the tree, so it doesn't have to be necessarily the whole tree, which would be a lot of data going back. But it supports all of this. And we also have something we call dynamic metadata. That is other type of metadata which is not defined within the VSS tree. You could, for example, have about availability. This could also be dynamic, that is changing over time, is one reason why we named it like this. So like availability information about the signal. Not all signals are always available, and so forth. And the third large addition to the standard is the access control. It was very briefly mentioned in version 1, that saying basically only that it should use JSON web tokens as the means for access control, but nothing more. But here in version 2, we have a complete specification of an access control model. And it contains two different authorization server. One that typically would reside in the cloud, the access grant token server, which the client must first contact to get, and this is where the authentication step of the client is handled. If its client is authenticated, and the client must also request a role, this access control model is role-based. If the server then grants that, it will send back a first token, an access grant token to the client. The client in the next step must contact the access token server, which is typically deployed in the vehicle, and send down the token it got from this first step, together with more information about what it wants to do, because it can use this token multiple times for multiple requests until the expiry time goes out for that first token. And then if it gets that back, it gets a new access token back. That is used in the third call, which is to the general, here it says Gen 2, but that's an old information, VISS version 2 server for the actual request for signals. The server here can then, will then verify that request by looking at the token. And it has some help, so to say, in doing that. Typically, it will ask the AT server for some help to do the actual signature verification and those parts. And it will also look into and use this selective access control model, because in the tree contains the information. So here is an example of where layering could be fits very well into, if you were in the previous discussion in the other room. You need to add in the tree information about which nodes are read only or read write and so forth. This information is inherited, so if you put the read write in the root node, then everything below will be read write, but you can move it further down, which means that you can have some nodes that are completely uncontrolled, unaccess controlled, and some that are read write and some that are read only and so forth. So you can do all of that. And all of this the server will have to verify before it decides whether the client request should get data or not. I don't think I go further into that, but at any point, if you have a question, just interrupt me. So now I would like to move over to the implementation of this server, which we decided a couple of years ago in the working group that we should not only write the specification, but also try to implement it. And the main point for that is that then we can quickly see whether our ideas work or if they were not so clever, and redo. Instead of leaving that until the specification is done and some like you guys come and shout at us. You can do that anyway, but we try to get at least some of those shouts away by trying it very quickly. So that's what we started, and we have implemented on this GitHub a server that has an architecture looking something like this. I will only say a few words about it. You have, of course, the clients on top, and then all of this actually constitutes the server as such. And the server is modularized, consists of different modules. We have up at this level what we call the transport managers, which here is only shown a WebSocket and HTTP, but we have also an MQTT. And the implementation is very scalable, so it's fairly simple for anyone to implement maybe some IP transport support for this, possibly. And could add that, and that could register into the core server, and then it would work fairly quick. When I implemented the HTTP manager, this was the first one implemented. It took me, but I was of course into it 2 days or something like that. So it's quite easy if you get the catch of it all. At the bottom, we have what we call the service managers, which also the architecture supports multiple. Today, we only have one, which is the vehicle tree. But if we were early discussing possibility to have multiple, that was partly in the discussion with Volkswagen and VW. They wanted to have a media service in here. But architecture supports it, but today we only have one, which is the VSS vehicle tree. And in the middle we have, we call the core server, which is, what it does is that it verifies requests that it exists in the tree, and that you don't do a write to a sensor and things like that. It uses the metadata of the tree and see, is it in the tree, and is it allowed to okay, was it me? Oh. Is it allowed to do what you want for that node, that signal, and so forth? If it is, it routes the request down to the vehicle server service manager that will then perform the request and send back the information. Today, this implementation, every one of these different blobs here are implemented as its own binary, its own program. And the communication in between here is Websocket. So they don't even have to reside on the same SOC, on the same processor. But right now I'm rewriting it so that all of this will be one single process, and this will be threads instead. Which will make it, I think, much faster and slightly more secure, since you harder to hack into IPC between threads than between processes, and smaller and faster and so forth. So I think that will be quite interesting for many to use that instead. But this model is quite flexible, or this implementation, because you can put this at other computers and anywhere in the world if you like. Okay, we also have some experimental additions here that is not part of the specification, and that's particularly some compression, where there is a protobuf-based payload compression that gets actually, because we use JSON here, and JSON, as you know, is text-based, and it becomes quite a lot of bytes. But both of these are binary compression, so you send binary, and of course you get it down. And I think it's like 500% or 5 times, so 5 bytes become 1 instead, so fairly good compression. All right, so if you want to run this, I thought maybe I should mention, it's a fairly complex system, so you need to do some stuff, and maybe the documentation on the GitHub is not super clear, but so I try to compress it here. So if you want to run it, you need first to do some configuration. You need to install what is called VSS/VISS version 2.binary file, which contains the tree. And to get that file, you have to clone the VSS repo, including the tools parts. And then you run make binary command, and that produces a .binary file with a different name. So you have to rename it and move it into the server core directory, so that when the server starts up, it finds this file with that name, because it only looks for that name. That needs to be done. Some components in a total tech stack might need another file which is called VSS pathlist.json, which is a JSON file containing all leaf nodes, the paths of all leaf nodes. That is used, for example, if you want to use the simulator that has been developed also for in the Covesa context on a different repo. I think we get the links somewhere later. That one needs this file and also some other clients that you might be interested to use that already exist. This file is generated from the binary file by the server when it starts up. And if you don't want to start the entire server and get that out and stop it and start again, you can do a dry run with that command. Then it just produces this and kills itself or terminates itself.
Sorry to interrupt, I just want to make you aware of time.
I'm very sorry. That's typically me. I just talk. Very good. And if you want to implement TLS, you have to do some configuration too. And then to start all those 5, 6, 7 different programs as the server, you use this shell script. Let's see. No, maybe I'm done now. This is just a client. Yeah, we have a different of clients. So you can find clients here, and this is this other CCS components GitHub where you can also find some clients. You can have a look at that. They can do different things. And with all of that, you should be able to have fun, we hope. Okay, now I'm done. Sorry for taking a little bit too much time. So now I leave to Andre to continue here. Thank you very much.
Maybe a few details like so for BMW.
Should I help you?
Why VIS? Why we decided to go this way? Or what was the motivation?
I just want to give you a short introduction about the boring slides, we had previously, and then I give you a short intro about the what I've actually done, and not only just the boring slides. And the idea behind this VIS, when I looked at that interface, and we have the VSS below, was we have a pretty nice standardized interface, and I'm this web guy, I don't know something about some IP or any issues. I don't want to deal with that, and then I said, yeah, okay, but every time when I need some data, I need to talk to these guys, and I have this interface, and I just want to do web applications, and then we tried to set up an environment where we can easily access, do simulations based on that interface, and that's where it mainly come from, and this is where our pains and gains are coming from. So every time when I'm from research, have an idea, you look at our fleet, and we have that high fragmentation of hard and software in the field, high costs involved testing and development. So if you have like an application and you try to spread it out in the fleet, you have to develop it 2, 3, 5 times because of different software standards in the car. Also, like creation of testing data, you have to put a recorder in the car, go on the Nürburgring, and then they say, hey, you're a software guy, you can't drive. Yeah, also you have like I have limited possibility for automated testing. So if I have my web technology running there, I have no data, or I have, like I said, put a recorder in the car and then do a drive for testing, and maybe then we have different conditions, which was also not so easy. Also the no local or decentralized access. So every time when I'm somewhere and I just want to code, I need VPN, something like that, for connection to our systems to get data out of it where I can test it. We have also, well, we have complex and long-lasting processes bringing new developers. So explaining them the APIs, explaining them the technologies, everything, which interface, standardized interface is solving for us. And even before that, we have no common understanding of available data structure. Now I can say, hey, that's VSS, that's the data. It's coming out like VISS, you can use it. And if you have any question, look at GitHub. Our gains, or my gains out of that idea is like we are fast and cost-efficient onboarding of new developers. We can easily create static and dynamic test data, which is a bit different. So in the past, we also had mostly static data, and we don't have like dynamic data when I wanted to test my application. I want to have supported automated reproducible testing, online, offline deployment. So which I will show you later is completely running on my PC. I have no I have one part of the connection where I need to record real life data of cars. This cannot be done offline, but everything is running offline. I have support of the complete VSS based standardized APIs, including some BMW integrations we have. The cool thing is I don't need to go to the Nürburgring. I mean, it's not cool for me, but it's cool for the company. And I can just say I can just put in some risky maneuvers, you know. So, like, yeah, if hitting a tree, for example. I can easily switch between development and production because it's one API, and I just need to change like where is the server running. And even I have, for our side, I have an easy end-to-end integration for our connected drive-enabled cars. So I can get the data out of that, and I can, for some reasons, the data I created in the simulator, I can put into our end-to-end environment for testing purposes. So how does this look like, and what I've did? I mean, in the first part of it, I started with this vehicle simulator. When the VSS is coming up, we did it on GraphQL. And this was pretty nice, and then the VISS was coming up and was standard in a version 2. And then I thought, okay, GraphQL is pretty nice, but it's Facebook. Let's have a look at this small, simple VISS API. And I started implementing a server which is running beside the simulator, and the simulator, which is general web interface where I can configure everything. We have added this VISS server or connection over mock service and have a completely running VISS server in the backend, which supports multi-tenancy. So you can simulate multiple cars with different users, whatever. So many developers can run on that. Based on that, we also moved that server to our internal head unit versions, or trying to do that, or currently doing that. And we also moved it to the standard AOSP. So this is also what I'm showing you later. I have a connection from the simulator over this VISS server running on my Android on my system, which is pretty cool. So I just can develop any browser apps running on Android, accessing a VISS. What I use as technologies, as you see, I'm a web guy, so TypeScript, Java, Angular, all these things, and everything is running inside Docker, so check it out. Docker Compose up, it's running. What was a pretty cool thing, we have specifications below that, which would make it pretty easy to keep the standard. So like the VSS and the VISS, so even I could understand it easily. And we also use just standard REST, interface standard like REST, WebSocket, GraphQL. I did not implement the MQTT yet. So it's not the full standard implementation, so sorry about that. And what do we have, or what do we offer as integrations on our side yet, is like we have the web interfaces which are running, which you can run everywhere, like REST, WebSockets, GraphQL for the simulator. We have integration for Android OS, and we also try to integrate in a Chromium browser. Yes. And what are we consuming? This is besides a bit of the VISS as a data source. We are enabled to, if you have a connected drive account, you can just enter your credentials and you can grab the data out of the connected drive, which is showing you in general inside the connected drive portal, and this will then transfer to VSS data and published via the VISS interface into the simulator. And we are able, as I mentioned, to move our data streams we have in our test fleet to VSS data and show it in the simulator for usage. What was the result out of that? I mean, the cool thing is to develop, I have a standalone system. I don't need to look at anyone and ask anyone. I just check it out running, and I have my VISS interface, and I can adopt any kind of data off it. I have a real-time access for data, so I can record a test drive when I'm driving from home to the company, and I can use that for later simulations. And I have a seamless access, so even I can work on in a coffee bar. What we're doing for tests and simulation, this is 200 plus. At the moment I looked, I think the VSS had around about 900 data points, a bit more. So in general, the 200 I just put in for management. but because it looks higher now, I can change it to 900. So it's so you can just completely configure which kind of data points you have within the in the VSS. It's just based on which VSS schema you load. Yeah, as I said, you have a direct simulation. If I press the button within the UI, I can directly have the new data in the interfaces by subscription or HTTP or in GraphQL mutation subscription, whatever. I can store my simulations and can replay them every time. And even like I said, for some testing vehicles we have, I can push the data back into the system and can say if our data pipeline is working correctly. And then even go on to the official APIs we have. And for rollout, it's really cool because I have, in our real-time system, we have GraphQL, and we can VISS for direct usage. We can limit it, so access can be limited, so that only permitted vehicles can be queried via the API. This was pretty nice. Like I said, we have real test drives where we can say, okay, if we find an issue in the field, we can work it in the backend, and I can easily switch. And this was the idea behind it, to hopefully our goals, and hopefully we'll achieve it. And I see that is possible, that we have real cost-efficient end-to-end development, testing, and integration of vehicles and data with standardized interfaces. So this was maybe the boring slides. Then I show you where hopefully the magic happens. So in general, normally I have also a login like with connected drive account. I just removed that for some showing purposes. We can only support more than 2 cars. These are just for local deployment. You have a combustion engine, electric vehicle, which has some pre-stored data configured. And here you just can enter the car. The car is loaded. I have only for my test purposes sub-service, or some sub-elements of the VSS in it, because I don't need 900 points for development. And as you can see, I can just run through the car, have it here, set, okay, I want to have a different ambient temperature, and I can just change it. The system accepts it. We have some kind of validation behind it. So if I can say I want to have ambient temperature like 2,500 degrees, it's a bit unrealistic. I mean, you can store it, you can save it, but it's only a bit unrealistic. This is the one part. This is like the static thing. The picture here is a bit nice, than just only having the tree, because if you show it to management, they like the pictures. We also have like interior view, because that we said when we simulate exterior, interior, maybe you want to display that. Here I don't have any points mapped, but I think I have some fun of the session. Yeah. Here also you can like, I mean, this is now a bit just for demonstration, but if you have like overview of the car, you can show it left wheel, right wheel, and if you change like the pressure of the wheel, you can directly display it there, and it's pretty nice, like for showcases. And now what's the pretty cool thing, I think, is like I can not only have like the static routing, I can also let this car drive around. I have some route prepared. So as you can see, and this is where I'm working, and this is where my boss mainly is working. And this is when I did something bad, and then I have to drive that road. And as you can see, I can just, it's like previously recorded, I can just keep the car driving. And then I see on the left side what kind of positions are changing. So GPS I entered here, and in general, the speed is changing. But that would not be the nice thing, like to have a car on here maps showing and a bit of pixels, you know. This is not what I wanted to show you. I also have this here, and that's my car running there on the simulator. I can just say, okay, give me a subscription of the latitude. Then, hopefully it works now. Then I just keep my car driving, and then hopefully my subscription will come in. And so this is where I can develop locally. So I have my simulator running in the background, and I get the update for the latitudes. The same thing I can do for every kind of value I change during the simulation on the left side of the tree. Yes, and the same thing I can do is, there is the subscription was broken because I messed it up. This is now my Android simulator running on my system. And there you can see I also have my data points in it. And let me show that to you. Now we have 11, 6, 3, 4, 6 something. And if I now, I can now access to see my local simulator via VISS. So the simulator is publishing, or I have a VSS server running on my Android locally, on my Android emulator locally. And this is also using a subscription against my simulator. And there I then get like the updates of that as well. And as you can see, driving the car in real time is a bit slow. So we fasten it up. So I have a new point running in here, which is 4581. And hopefully we will get it there as well. 4581. And yeah, this is only the idea where we started, and to see how such an interface could help us to increase our time in testing, developing, and rolling out application based on, as Adna mentioned, browser-based apps and things like this. Yeah, and this is the app development we have. Yeah, and I think for because I did it, it's pretty nice. I did it not alone, but yeah, I think it's pretty nice. So yeah, that's it.
Great. I think you were in a session from the Android SIG, weren't you? So they were talking there about converting between VSS data and Android. Speak to that part. How you do it?
I have the VISS server, which I have running on the Android, is not only consuming my simulator data. If I put it, for example, on the car, I also have a VHEL abstraction within it. So we also thought about that.
You bypass, you're not going through VHEL.
No. I have put the VSS server on the VHAL. So I did the mapping. So as Adnan mentioned in the previous, I did not made it with layers. So I cannot just roll out layers and say, okay, that's the VHAL adaptation and that's my VSS adaptation. I mean, if I could do anything if the VISS server collected to VHAL, I can put it on a standard Android if it is based on the VHAL and it would run on a Volvo, on a Renault, or whatever. For that reason, I think it's cool. I did it here mainly for just showing what VISS interface helps us. And I mean, like I said, the VISS has 900 data points, and I cannot simulate 900 data points over the VHAL. And yeah.
The overall idea was like when we decided to do Android is actually to build on the existing elements of VHAL. So to have like kind of like this compatibility. What would help us is definitely that we see like VSS description inside of VHAL. Then it's even less work.
Yeah.
Yeah. And it kind of like makes sense through all pipe of the company to bring the VSS description inside the vehicle itself. But as Andre said, this part of the VISS on the IIS system, we see that it would be quite limited because it's mainly like right now in this case is defined for the browser purposes. And the idea of the simulator is that actually when we talk with our browser team or our backend team that prefer more maybe like technologies like GraphQL or Kafka, that they can all play around on the same tool and basically have like a testing across different like API deployments.
Yeah. Okay.
As long as they speak VSS.
Otherwise, they will be shoot.
Yeah.
Yeah, that's it. Then are we closing? No further questions?
One question.
Yeah.
Do you find it easier to play with this protocol than with GraphQL? You still have both, I guess?
It was not. Yeah, I think it was easy. It was easy to use. I mean, I also changed some. I also changed some or joined some calls and said, oh, maybe we could change that a bit because I have. I mean, sometimes with the protocol I had these issues with if I implemented the simulator for multi-tenancy running on the back end, and if you look at the protocol, it was designed to run on board. Or that, and then there were I had some issues related to how I put my use case into that protocol, which is what not initially designed for. But the usage and the documentation was fine. So I did not have to ask or call anyone to explain me how to use it and how to implement it.
Like maybe for the
VISS, you mean?
Yes.
And how does that compare to GraphQL? I mean, let's face it, you said,
I mean,
I have GraphQL, but that's Facebook. And then you
no, that was just a joke. No, that was just a joke.
Let's first make it clear, like, right, there is no one single tech stack that you will use like across the whole company, right? Like each team is kind of like driving its own implementation based on the use cases that they have, right? And our idea is that the content that goes to those APIs is important. How they realize the API is kind of like less important for us, right? So when we talk about like, for example, the backend guys or someone who would like to kind of implement something really simple and query the data occasionally from some database or system, GraphQL might be good. But if we talk about like solutions where you would like to have like a standardized description, you need some sort of like interface specification for it in order to align it across different like OEMs, different companies and so on. Same thing goes like once we start talking, for example, with our guys that are doing the data analytics, they don't want to hear these things. They want to go Kinesis, Kafka. When we talk about the encoding mechanisms, you go towards the Avro, Protobuf, and so on. But again, for us, is go VSS inside.
I mean, the GraphQL is still working and I'm still implementing it. So it's nothing that I have something against GraphQL. I mean, the only thing is what I mentioned to say, the VISS is a W3C standardized interface now, and which is, I mean, it's a standard. You can use it with W3C technologies or their described standardization. You don't need an external lib. You can do it with every browser. You can do it with any kind of public implementation. And that was, you know, I could say now I felt responsible to support that. And
RESTful interfaces more standard than GraphQL. I guess that's what you're saying.
yes. And, but like I said, there are reasons for using GraphQL instead of this VISS interface. And we have implementations in the backend just using that still. And I think they will not move to a VISS interface, and that's pretty fine. But as you see, it's still working.
I just wanted to get more detail on
Maybe now, like when you see what we're talking here, you can maybe as well like understand better like that figure that Graham showed, like different endpoints, different technologies, same language.
Maybe. Yeah.
Give it a try.
I definitely am thinking about Graham's pictures ever since I don't want, so I'm trying. Okay, thanks.
So I guess this concludes the session then. Yeah.
Have a lunch. Wow. And then this afternoon we're back in the big room. Data servers and data storage.